So in this video, I'm going to be going through sections 1 and 2 of chapter 1, which deals with straight line and linear functions. And a lot of you, based on the fact that you're in college, you probably had courses in high school that went over a lot of this material. So hopefully, a lot of this material will look very familiar to you. But if not, we'll try to handle that as well. But keep in mind, because it is considered to be this is a chapter which is reviewing prerequisite skills, it does give a good bit of information pretty quickly. So if you're having trouble keeping up, make sure that you are reaching out for help. So the first thing it mentions we're going to talk about here is section 1 is the Cartesian coordinate system. The Cartesian coordinate system is actually an offshoot of a number line, and then most of you know what the number line is. I'm not going to get into the whole description here, but essentially, especially whenever students are introduced to adding and subtracting negative numbers and doing operations with negative numbers, that this comes in handy quite a bit. The Cartesian coordinate system is basically me taking two of these number lines and making them perpendicular to each other. So we have the origin is where the two number lines cross each other. The x-axis is the horizontal axis. The y-axis is the vertical. And so when we give an ordered pair, it's always x then y. So the first one's telling you if you want to plot a point, how far left or right of the origin you have to go. And then the y value tells you how far up or down from the origin you have to be to plot that point. So to go over, the axis also divides the plane into 4 quadrants. And it works in a counterclockwise fashion. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4, back to quadrant 1. So here both the x's and y's are positive. In quadrant 2 the x is negative, the y is positive, so forth and so on. In quadrant 3 they're both negative. In quadrant 4 x is positive and y is negative. That's what all these notations to the left really are just saying there. So let's go through this first example. I'm going to have you do this at first, so I'm going to pause a moment to ask you a number of questions and see if, you're correct, and we'll go over this problem. Okay, so now that you had a chance to review some of the answers from Play Pause It, let's go through these. Which point has coordinates 4, 2? Which means we're going to start here and go 4 to the right and up 2, and it looks like that's A, so that's point A. B, when I look at B here, it seems as though I want to plot B, we went 5 to the left, so the x-coordinate is -5. The y-coordinate is a +4. Which points have negative y-coordinates? Well, negative y-coordinates is anything below the x-axis. Notice we're using the x-axis as a frame of reference for that. And sometimes that's going to happen. You have to be sure well, the x-axis, if it's below it, it's going to have negative y values. The x values could be anything. So it looks as though E, F, and G would be the ones there. Which point has a negative x-coordinate and a negative y-coordinate? So I'm looking for something that's in quadrant 3. And that's E. Negative. Looks like it's at -2, -3. So, oh, not this one. E at -2, -3. Which point has an x-coordinate that is equal to 0? Well, if it has an x-coordinate equal to 0, that means there's no left or right movement. It's going to be somewhere on the y-axis. And so that looks like that's going to be point F. and which point has a y coordinate that is equal to 0. That's going to place it on the x-axis, and the only point I have on the x-axis is D. So hopefully that wasn't too much trouble for you, because it's something that it's usually start off in algebra with. So, moving on to something that's a little bit more problematic. When we start finding these coordinates, we start needing to find the distance between them. And, if they're oriented horizontally or vertically from each other, I could basically just count to see where they are and know what the distance is. However, if they're lying diagonally from each other, which means, I don't have a common x coordinate or a common y coordinate between the 2 points, I'm going to have to figure out what its distance is. I can't just count. So what we do is we have this distance formula, which says D equals the square root of x squared minus x1. It's basically the difference of your x coordinate squared plus the difference of your y coordinate squared. So if I wanted to find the distance between 1, 3 and 1, 7, I would take the square root of 4 minus 1 squared plus 7 minus 3 squared. 4 minus 1 is 3. 3 squared is 9. 7 minus 3 is 4. 4 squared is 16. Which gives me the square root of 25, and the square root of 25 is 5. So the distance from 1, 3 to 4, 7 is 5 units. I'll do the same thing over here. D is going to equal... Now, it doesn't matter which order you subtract them. Okay. Generally, if I do the y coordinates in this order, I'm going to do the x coordinates in the same order. But that doesn't even matter in this one because of the fact that we are eventually squaring them. So if I do negative 2 minus 10 squared plus 1 minus 6 squared, negative 2 minus 10 is negative 12. Negative 12 squared is a positive 144. 1 minus 6 is negative 5. 5 squared is 25. So that equals the square root of 169. And the square root of 169 is 13. Now keep in mind, you're not always guaranteed to have whole numbers for these or integers for these. Sometimes you will have decimals. Sometimes you will not be square rooting a perfect square. It can happen. So don't get alarmed if you see that in anything that you practice along the way. It certainly can happen, and oftentimes does happen. A grand tour of 4 cities begins at City A and makes successive stops at cities B, C, and D before returning to City A. If the cities are located as shown in the accompanying figure, find the total distance covered by the tour. Well, AD, so if I look at this thing here, if I look at this side's pretty easy. Since A and D happen to be horizontally related to each other, they lay on a horizontal line away, all I have to really do is count. Going from negative 800 as an x-coordinate to 0 is 800. So I could say that AD is 800, and I guess they're showing miles here. They're not really saying what the units are. The other ones, CD is another easy one, because CD is vertical. In CD, I'm going from negative 800, 0 to negative 800, 800, which means that CD is also 800. I really shouldn't have a line above it because I'm doing a measurement. The other ones, however, I'm going to need some work because I got to figure out what this distance is, and I got to figure out what this distance is. So I'll call it D1 and D2. So D1 equals, if I go between 0, 0 and 400, 300, I'm going to have 400 minus 0 squared plus 300 minus 0 squared, which means I'm going to have 160000 plus 90000, and that's going to give me 250000, and the square root of that is 500. So I could say that AB is 500 because that's what D1 was. And then for BC, which is D2, for D2, I have the x-coordinates 400, negative 800, so I'm going to do 400 minus a negative 800 squared plus 300 minus 800 squared. 400 minus 800 is 1200. Squared is 1440000. 300 minus 800 is a negative 500. Squared is a positive 250000, which would give me 1690000, which, when I take the square root of that, gives me 1300. So when I add these together, I have 1600 plus 1300, which would be 2900 plus 500. This is 3400. And they're not saying what it is. I mean, I'm going to assume it's miles. It could be meters, kilometers. I don't know what it is. But whatever the units happen to be, that's how you figure it out. Distances can also be used, I mean, because when you do the distance formula, and to kind of go back to something really quick here before I move on too much. When I do the distance formula, what's really going on here is if I have like my one point and my other point here, and I'm trying to find this distance, what it's really saying is that if I find this distance here, which is my x2 minus x1, if I find my y distance here, which is my y2 minus y1, I should be able to find this. Well, if I square these, I would get this distance here squared by the Pythagorean theorem. And that's where the formula comes from. The distance formula is just another version of the Pythagorean theorem. So with that being the case, if I deal with other situations, I could probably use the Pythagorean theorem in a similar way to find the solutions to various things, such as this problem right here. At a distance of 4,000 feet from the launch site, a spectator is observing a rocket being launched. Suppose the rocket lifts off vertically and reaches an altitude of x feet, as shown below. What is the distance between the spectator and the rocket when the rocket reaches an altitude of 20,000 feet? So basically you have the spectator here. You have a 4,000 foot space between here and the launch pad. And now we're saying this thing is, the rocket's at 20,000 feet. We want to figure out what this distance here, the distance between the spectator and the rocket. So anytime we're trying to measure, like, a distance between something, it's always a straight line and the shortest straight line path to that point. So the distance here I'm looking for is just going to be the square root of 20,000 squared plus 4,000 squared. So I'm going to have 4, 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 6, 1, 2, 3, 4, 5, 6. And That's going to give a grand total of the square root of 416. 1, 2, 3, 4, 5, 6. And I take the square root of that. I do actually get 20,396 feet approximately. Somewhere in that neighborhood. 416 and 6 zeros is not a perfect square, I don't believe. Let me do a quick calculation here. No, it's actually like 2396.078, so it's pretty close. So, but that's the distance between the rocket and the spectator at that point. And a lot of times when you're working with the square root function, you're going to see that you're going to have a lot of irrational answers from time to time. So, the equation of a circle, it's pretty simple to work with. The thing you have to remember is that these are really the values that would tend to be filled into an equation of a circle. The x's, the y, the equal signs, the pluses, the minuses should be there. One of the things you have to keep in mind, though, is sometimes when you look at the equation of a circle, you may not have a minus sign in it between the x and the whatever number follows it. And a lot of people just overlook that and don't think, okay, what does that mean? Well, that means for us, when I look at this situation in example 5, first I want to find the equation of a circle that has a radius of 3 and a center at -2, 4. So this is h, this is k, this is r. Pretty straightforward. So when I start writing the equation of the circle, I'm going to have x minus -2 squared plus y minus -4 squared equaling r, which is 3 squared. Inside the parentheses, I'm subtracting negatives, so I end up with x plus 2 squared plus y plus 4 squared equaling 9. And that's the equation of the circle that's being described there. Sometimes if they reverse it and say, okay, here's the equation of the circle, tell me what the radius and center are. I'll have students that'll tell me on this circle that the radius and center are at 2, 4 because they're just looking at the numbers there. Well, those plus signs, are not part of the defined structure of the equation of a circle. I should have minus signs there. And if I don't have minus signs there, that means that something occurred to make them change to a plus sign. And that's the case that I'm multiplying by a negative. So I'd have to know that, excuse me, that the two, that if there's a negative x value or a negative y value, it's going to put a plus sign into the formula and vice versa. The equation of the circle has a center at -2, -3, and passes through 2, 5. So if I start filling in the information, I have x minus -2 squared plus y minus -3 squared equals, well, I'm looking for the radius. Well, they don't tell us what the radius is. They're telling us that the circle passes through 2, 5. So basically what they're saying here is, okay, and I'm not going to draw it super well. We have -2, -3 as the center of the circle. So this is -2, -3. At 2, 5, the circle is passing through there. Which means if I find the distance between these two guys, that is the radius. So I'm going to say, okay, the radius of this circle is going to be the square root of -2. I don't know why I put a comma there. Yikes. -2 squared plus -3 minus 5 squared equals, I'm going to have -4 squared, which is 16. I'm going to have -3 minus 5 is -8 squared is 64, which basically gives me the square root of 80. Not a perfect square, but here's the good part about it. I don't need it to be a perfect square because I know that r squared, I know that r is the square root of 80, and I'm going to be squaring it as part of the formula. So when I simplify this, I'm going to have x plus 2 squared plus y plus 3 squared equaling, if I square a square root, those are inverse functions, they just cancel, so I would get 80. And those are the equations of the two circles that's being described here. The next part of this lesson deals with section 1-2, which deals with straight lines. Which I don't like them using the term straight lines because lines are straight. If they're not straight, they're curves. And that's the way they're defined in math. To say straight lines is kind of redundant. But that being said, we're only looking at linear things in this situation. And the slope formula is one of the first things that you may have learned in an Algebra 1 course when you started graphing lines. And there it is. Basically what it is, it's measuring, how far you're rising versus how far you're running, which that's a way rise over run. So rise is like how far you're moving up and down, up or down. And the run is how far you're moving left or right. It's always the y's over the x's. Y's, rise, they rhyme. That's how I try to tell people to remember that. It's always the y's on top. Here it's more, it does matter more how you set up the subtraction. Again, it doesn't matter which point, y coordinate you start with. I mean, I could say just as easily it's y1 minus y2 over x1 minus x2. That would also be sufficient. It's just so that, whichever point I'm getting the y from, I should be getting the x from that same point in the first position down there. I don't want to mix them up along the way and end up getting the wrong value. Find the slope of the line that passes through the following coordinates. So, I mean, if you have a graph and if you want to plot the points, 4, 6 would be right here. 7, negative 4 would be right here. I could literally count, I'm moving up from negative 4 to 10, that's negative 4 to 6, that's 10 units. And I'm moving left 3 units. So I could say that the slope here is negative 10 thirds. And we usually leave them written in fraction form so you can tell what the rise and the run is. Could you have used the slope formula? Sure. If you used the slope formula, you would have gotten the same thing. You would say, okay, well, I have negative 4 minus 6 over, now since I chose this one first, I got to choose the 7 first. And I get a negative 10 over 3, which is negative 10 thirds again. So it doesn't matter if you don't have a graph in front of you, it's kind of pointless to count. Or if you get a point that's like, okay, what are the coordinates at this point right here where it's not crossing through one of the grids? That gets to be a little bit more difficult, and you have to sometimes use the point and calculate it using the formula rather than using the lines here. But you can certainly do it that way. 2, 7. Here's 2 where 2, 7 is. This was nothing. I just was trying to make a point with that. Negative 6, negative 1 would be right here. So again, if I go from negative 1 to 7, that's 8 units. And when I go from negative 6 to 2, that's 8 units. So basically, the slope of this line is 1 over 1, or just 1. For C and D, it's important to see what's going on with these in both formats. If I plot 4, 7 and 8, 7, the line that passes through them is right here. it's a horizontal line. And if I were to use the slope formula on that, I'll come up here with it. My slope would be 7 minus 7 over 8 minus 4, which is 0 over 4, which is 0. 0 divided by a number is 0. So it seems as though if I have a horizontal line, my y-coordinates are going to cancel each other out on top and make it a 0. So I'm going to have a slope of 0. So we say that the slope of a horizontal line is 0. When I look at D, 6, negative 2, so I'm looking at right here, 6, 3, this is a vertical line. If I do its slope, I'm going to have 3 minus negative 2 over 6 minus 6, which is 5 over 0. Now we're not allowed to divide 5 by 0. It's actually an infinitely big number if you try to do that, but it's really not defined because we really don't know what infinity is either. So this is undefined. And you would see that would happen with any vertical line, so the slope of a vertical line is undefined. So, and that's what some of this stuff is going to be, that's what some of this stuff is saying here. Oh, I thought I had another, okay. I thought I had a graphic there. Oh well. Maybe I'll think of something else. Okay. Parallel lines. Lines are parallel if and only if their slopes are equal or their slopes are undefined. So basically, if they have two lines not touching one another, they have to have the same slope. And if they're both, and if one is vertical, the other is vertical. So they're asking the question here: are these lines parallel? And we want to do the slope of AB and CD. Well, the slope of AB in this instance, I'm going to have negative 6 minus 2 over 2 minus 3, which gives me a negative 8 over a negative 1, which is 8. When I look at CD, the slope is going to be a negative 18 minus 14 over a negative 3 minus 1. That equals a negative 32 over a negative 4, which is 8. They're both the same slope, so in this case, AB is parallel to CD. That's the official symbol we use for parallel. You may see it from time to time. In the second instance, if I calculate AB, the slope of AB, I get negative 1 minus 2 over negative 1 minus 2, which is negative 3 over negative 3, which is 1. And here I'm going to have 3 minus negative 1 over negative 3 minus 1. So I'm going to have 4 over negative 4, which equals a negative 1. Those are not equal to each other. So AB is not parallel to CD. As we will learn in a little bit, they're actually perpendicular to each other. One has itself as a reciprocal. They're opposite reciprocals, and we're going to talk about that rule momentarily. So you have three different equations of a line, though. The equations of a line, you have point slope form, which is, where y1, m, and x1 would normally be numbers. You have slope intercept form, which is the most popular way because it's also in what we call function notation, where y is a function of x. But really what's happening here is these two values would normally be numbers. The y and the x would stay where they are. And you have this form down here where the a, the b, and the c. They call this general form. Sometimes they call it expanded form in different textbooks. Um, what's good about these two is that, you have plenty of information about the line just based on looking at the equation. So the information is easy to see. Whereas in general form, it's not really easy to see. You'd have to do some kind of either mental calculation or work it out on paper to figure out what the actual equation of the line is. So, but even though this is the form that's usually most often sought, a lot of people overlook this because a lot of times you might have a situation where this is much easier to get than the slope-intercept form, and you could get the equation of a line really easily. And even if you don't need that format, they want it in the slope-intercept form, it's pretty easy to convert point slope into slope-intercept. So let's go back and show you. Now, as we go through these next examples, we've already done some of the work on this because we found the slopes of them back in example 1. So I'm not going to go to a bunch of hardship here and say, okay, m equals -10/3 for this one, m equals 1 for this one, m equaled 0 for this one, and m equaled undefined here. But for the sake of argument, I'm going to also remember it as the 5/0 that we found it to be, for reasons I'm going to get into momentarily. Because what I'm going to do now is I'm going to use point slope for A, which means I'm going to pick one of the points. It doesn't matter which one I pick. So I'm just going to pick the 4, 6. And according to point slope form, y minus this y coordinate would be y1. So 6 equals -10/3 times x minus x1. x1 would be the x coordinate of that point, so 4. So this is the point slope form. If I wanted to put this into slope intercept, it wouldn't take much more effort. I would first have to simplify the right hand side. And then I'm going to add 6 to both sides. So basically, I want to get y by itself, essentially. So -10/3 x plus 40/3 plus 18/3, because that's what 6 is. I'm adding 6 to both sides. And so y equals -10/3 x plus 58/3 is the equation of the line in slope-intercept. Excuse me. So, that's not a big deal. To convert one to the other. Okay. Now, I could just, for B, I'm going to show how to do it using just starting with the y equals mx plus b. Basically, it's kind of a different handling. Whereas I just mostly plug numbers in to get point slope and then just manipulate it. Here, if I want to find it in slope-intercept form, well, I know that m is 1. And usually if I have a coefficient of 1, I don't write the 1. What I'm going to do is I'm still going to pick one point, and I'll pick the first one. That's what I'm going to do for all of them. When I pick the first one, I'm just going to substitute it in for what they are. This is an x-coordinate. This is a y-coordinate. So -1 is what y equals when x equals -6. So to solve this, I have to add 6 to both sides, and I get that b is 5. So my equation in slope-intercept form is y equals x plus 5. Slope-intercept. So, you could go right to slope-intercept. You just have to know how to what you need to do with the coordinates in both cases. Point slope, it's pretty much, okay, insert it where it needs to go. Same thing with slope slope intercept, but you always have to make sure when you go back to the equation, you have the y and the x there. I'll have students who'll write a statement like -1 equals -6 plus 5 and say that's the equation of the line. It isn't. The equation of a line has an x and a y in it. That just calculated one coordinate for that line. Now C was our horizontal line, which had a slope of 0. So if I try to treat it the same way as I did the previous one, y equals 0x plus b, and I'm solving for b. Notice I'm keeping the 0 there for no apparent reason, but I'm going to just use the first point. So, okay, 7 equals 0 times 4 plus b. Well, 0 times 4 is what b is. So if I do y equals 0x plus 7, well, 0 times x is nothing. So it's just y equals 7. And so when you look at the equation of a line, if it just says y equals a number, it's a horizontal line, and it means that all the y coordinates are that number. In this case, is 7. Much the same with D. Here's why I kept the slope as 5 over 0 for this, because that's the undefined value. Again, if I start doing the same thing, say, okay, y equals 5 over 0x plus b. I want to solve for, I'm going to use 6, -2, so -2 equals 5 over 0 times 6 plus b. When I subtract b from both sides, it's kind of a more complicated equation. What ends up happening is I multiply by the 0, and I end up with 0 over here equals 5 times 6, which, that doesn't make any sense. It's not going to be solved in this way. That's because of the undefined slope. But basically the reason why it's happening is because of the fact that my x's canceled each other out. Much like when you look at here, you see, okay, well, I have a common y. That means it's a horizontal line, and the y's are always 7. I kind of look at this the same way and say, well, they have a common x, and the x's are always 6. So x equals 6 would be the equation of a vertical line. A lot of the stuff we were doing with the other ones, trying to put it into a function form wasn't working because this isn't a function. It's a vertical line. It fails the vertical line test. I mean, it sounds kind of weird. The vertical line fails the vertical line test, but that's exactly what it does. So, to kind of summarize, and I didn't want that to appear like that. There we go. So basically, to sum it up, a vertical line always has the form x equals some number. Horizontal line always has y equals some number. And the point slope form, slope intercept form, and general form are ones that we've already talked about. So now, one of the things about expanded form, which is what these in, or expanded form, general form, whichever you want to call it, is that, unlike the other two, if I look at the equation of a line in point slope form, I could tell you what the slope is, I could tell you what a point the line passes through is, and from there I could draw the line. For slope intercept form, I could tell you the slope, I could tell you what the y-intercept is, which is another point that's on the line, and if I have that information, I can draw the line. These don't tell you anything. I mean, the only way to possibly get any information out of this is either to plug numbers in and get some coordinates, or to actually do what they're asking you to do here, to put it in slope intercept form, which is what I'm going to do since it's what's asking me. And all I like to do is, to put it in slope intercept form, don't make it more than it is. It just basically means solve for y. It means get y alone. So on the left, I'm going to subtract 2x from both sides to get 4y equals -2x plus 14. I'm choosing to write it that way because I know that when I write the equation of a line, it usually, in slope intercept form, it starts with some number times x. So I want x in the first position. And I'm going to divide both sides by 4. I have to keep in mind that when I do this, I'm dividing this entire quantity by 4, and there's 2 terms in it. And division gets distributed much like, multiplication does. So negative 2 divided by 4 is a negative 1/2 x. 14 divided by 4 is the same thing as 7/2, so you can write it as 3.5 if you want. But there you have it. For B, I'm going to add 24 and subtract 5x from both sides. So 5x was subtracted, 24 was added. I'm going to divide both sides by 8. I get negative 5/8 x. And remember again, since I'm dividing both sides by 8, it gets distributed. So 24 divided by 8 is 3. So pretty straightforward with that. So sometimes they're going to ask, most of the time when they ask you to write an equation, they're going to give you at least one point that it passes through and a means of finding the slope of that line. Because those are the 2 pieces of information you need to write any equation of the line. We just don't tend to expand it and put it in expanded form very often because, well, one, there's the whole, expanded form will have many different equations represent the same line. That's another issue you'll see with point slope form. But it could be done. I could write the equation of a line in in any format as long as I know the slope and I know a point that it passes through. If I'm missing one of those pieces of information, I can't do anything. So we want to write the equation of a line passing through negative 5, negative 4, and it's parallel to the line passing through negative 3, 2, and 6, 8. One of the things that I see students do in problems like this is that they'll mix up the information for the 2 lines. There's 2 lines being referenced here. We're looking for the equation of a line passing through negative 5, 4, and it's parallel to the other line. This is what we're looking for. This is our answer. Now I need to know what the other line is, so I want to use a different color here. There we go. But we have a line that passes through this as a second line. We need to know information about this second line to find information about our line. But I don't want to start putting coordinates for this line into the coordinates for the line that I'm looking at or looking to find. So what I need to know, well, I know for our answer, again, the 2 pieces of information I need is I need the slope and a point it passes through. I'll just say it passes through PT. Well, I have the point it passes through. That checks. I need the slope. Well, since I know it's parallel to the line that's passing through those 2 other points, I know it's going to have the same slope as the other line given here. So if I find the slope of that line, I'll have the slope of my line. So I'm going to take this line here and say, okay, I'm going to find the slope. So I'm going to take 2 minus 8 over negative 3 minus 6. And I get a negative 6 over a negative 9, which becomes a positive 2/3. So that's the slope of the line that passes through those 2 points. Can I find the equation of that line? Sure, but I really don't need to. The only part of it that's going to be the same with my line is the slope. So I now know the slope of my line. So our answer is going to have a slope of 2/3 and pass through negative 5, negative 4. Now, it doesn't say what format to put it in, so, if I just want to say, okay, well, y plus 4, it's actually y minus negative 4, equals 2/3 times x minus negative 5, which would be a plus 5, that would be fine. I'd be done. If it said I had to put it in, slope-intercept form, which sometimes you'll see problems that'll ask you to do that, then, I have to go a step further. But, I mean, I could actually give that as an answer and it'd be sufficient. But if I wanted to solve it for slope-intercept, I will distribute the 2/3. I'm going to subtract 4 from both sides. Now 4 is the same thing as 12/3. So I'm subtracting 4, or I'm subtracting 12/3 from both sides. And I combine like terms. The y equals 2/3 x minus 2/3. So that's the equation of the line and slope-intercept. So, but this is the general way you're going to find information for any line. You need to figure out what its slope is and then the point it passes through. So, now the other type of line that we haven't talked about yet, I mentioned briefly earlier, but now we're going to mention it, are perpendicular lines. Lines that are parallel are going to have the same slope. Lines that are perpendicular are going to have what we call, this description here basically means opposite reciprocal. Since many slopes are represented as fractions, what you're going to see between the slopes is that when you compare one to the other, you're going to see a flipping of the fraction, and you're also going to see a sign change. So if one's positive, the other one's negative. And then, when you look at the first one, the first one's numerator is going to be the second one's denominator, and vice versa. So that's how you can find the slope of a perpendicular line really easily. So here again, they're giving us two lines. They're saying, okay, we're looking for a line passing through a -a2 and it's perpendicular to another line. Let's go put it here. That line is this here. So this is what we want. This is the line given. So I have to figure out the slope of this line first, which is written in general form or expanded form or whatever way you want to call it. Different textbooks call it different things. So I'm going to solve this for y. So I'm going to subtract 4x from both sides. And I'm going to divide both sides by 3. I'm going to distribute it. And the part I'm looking at here is -4/3. That's the slope of this line. Our line, the one we're looking for, then, for it to be perpendicular, its slope has to be, well, since the line we were comparing it to has a negative slope, ours is going to be positive. The fraction, I'm going to flip it. Instead of having 4/3, I'm going to have 3/4. So that is the slope of the line that we have. We also know it's passing through -8, -2. So again, if I'm satisfied with using point slope form, that's a suitable answer in point slope form. But if I don't want it in point slope form for whatever reason, because either they're telling us not to or you prefer the other one, and for graphing purposes, that's another thing. If you want to be able to graph the line, having it in slope-intercept form is what you want to be able to do because, if you're graphing on the calculator, because that's the only way it accepts information is if you input it as a function. So again, I'm just going to solve this for y. I'm going to simplify the right-hand side, so I'm going to have 3/4 x plus 6, because 3/4 of 8 is 6. Subtracting 2 from both sides, I'm going to have y equals 3/4 x plus 4. So that would be the slope-intercept form. And that's all I have for this video. So if you have any further questions, please make sure to ask me about them in class. But until next time, have a good day.